Storage has always been a key component of computing. However, the earliest computers didn't have the ability to store their own files. In 1801, Joseph Marie Jacquard developed a loom, for which the weaving patterns could be programmed. The program in this case was instructions for how to set the loom to achieve a particular pattern. The necessary information was stored on a series of paper cards with holes punched in them. When Charles Babbage in the 1820s and 1830s designed what's now considered the first general-purpose computer, his design used this method for storing data on punched paper cards. And this method of storing computer data on so-called punch cards persisted for many, many decades, and was still a popular means of storing data as recently as the 1970s. A program would consist of a stack of punched cards, where each statement got its own card, and any data might be on a separate stack of cards. Although the computer wouldn't remember a program for you, you could hang on to those stacks of cards, your files, and feed those cards into the computer again in the future, each time you ran the program. Clearly, we're much better off these days being able to use digital files. But the notion of maintaining our data long-term so that it can be retrieved and reused still remains. Our files today sit in digital storage, whether inside the computer or at a remote location. And in order to be used, these files have to be brought into main memory. When we run a program, we're bringing that program into main memory and executing it. Executing means that we let the processor actually process all the commands given. And when we read in data from a file, for example, loading a document into a word processor, we're transferring the data in that file to main memory, where it can be used by our program. In this lecture, we're going to learn more about the process for how our program can interact with those files sitting in storage. Whether our data file is something that already exists before we run our program, or it's something we'll create from within the program, in either case, we need to form a link between our program and this file sitting off somewhere in storage. Files are closely tied with strings, since the typical file format that we'll write to and read from will essentially be one long string. The locations of those files are also given by strings. So, we'll also look more closely at how we work with strings. There are basically three things we need to do with data files in our programs. First, we have to make a connection with the file. We call this opening the file. We have to tell the computer that there's this thing outside of our program that we're going to be using inside of our program for input or for output. Second, once a file is opened, we'll eventually start working with it, actually reading data from it or writing data to it. Finally, once we're done, we'll close the file. The program has to say that we're done with the file. This is going to break the connection that we made when we opened the file. Closing the file makes sure that everything in the file is left in a nice condition so that nothing is corrupted. Also, it prevents us from accidentally opening too many files at the same time. Let's look at the open and close operations. To open a file, we can use the command Python helpfully calls open. Here's what an open command looks like. First, we need a name for the file. This is the name that we're going to use for the file inside our program. It's the name that we're going to use to refer to whatever that file is when we write our code. It's a variable that we can name just like any other. And let me be clear. The name we use inside of our program doesn't have to have any relation to the name of the file in the computer itself. It's just our internal way of thinking about the file. I like to compare names inside the program to job titles that we give to people. For example, the Constitution talks about things that the president does, such as, the president can veto legislation. That's true regardless of which particular person is president at the time. Now, when we inaugurate a president, we can connect the president with a particular person. We form this link between the office and a particular person, like Jefferson or Lincoln. But when we talk about the president's duties and powers, it doesn't matter who the particular individual is. Similarly, our internal name for a file is a variable whose name makes sense within the context of our program. When we open a file, we'll make a particular connection between that internal variable that we use in our program and the specific actual file stored outside of the program. In this case, the name of the variable we'll use is myFile. We then need to assign an actual value to that variable, so we have the assignment operator, the equal sign. Next comes our open statement. Notice that it has parentheses right after it. Inside the parentheses are two strings. The first of these strings is the name of the file in the computer system. This is the name of the file that you would see if you looked at a file explorer or a directory on your computer. If you create a file of some sort and save it, this is the name you use to save it. In this case, the name of the file is filename, but it could have been input.txt, or some other name, like document1.dat, or whatever name the file system needs. Okay, the final part of the if statement is a second string, and this string tells the computer how we're planning to use the file. If the string has the letter R in it, it means that we're going to read from the file. Basically, it's going to be giving us input. If it has the letter W, it means we're going to write to the file. Basically, it's where we can put our output. And if it has the letter A, it means we're going to append to the file. That means that we're going to write to it, but we're not writing from scratch. We're just going to add on more stuff to the end of an existing file. You should know that if you try to open a file for reading and the file doesn't already exist, you're going to get an error. Obviously, it can't form a link to read something from a file that doesn't exist. If you open a file for writing or appending, it'll create the file for you if it doesn't already exist. If you open a file for writing and the file already exists, you'll write over the old version. So be careful when you write to files. Let's practice this. Say you have a program and you know that you'll want to read in data from one file and write out data to another. You want to get your input from a file called mydatafile.txt, and you want to output to a file called results.txt. How would you open those two files? Well, you would first have to pick an internal variable name that you want your program to use for the two files. In this case, I've chosen in file for the input file and out file for the output file. Then I call open on each of them. First, I give the name of the file, either mydatafile.txt or results.txt. And then I write R for the one I'm opening to read from, and W for the one I'm opening to output to. Okay, so open was our way of creating a connection. And so to break our connection, we're going to need to close our files. The notation here might look a little weird to you at first. As we learn more about Python, it will make more sense. But for now, just know that this is the command you need to close a file. You start out with the name for the file variable. This is your internal name that you've been using. In the example, it's myfile. Then you add on a period, the word close, and two parentheses. That's it. Yeah, I don't really expect you to understand why you have that notation right now, but just know that this is the way to close your files. So, when we deal with files, we have some code like what you see here. First, we open the file. Then we do some stuff. Then we close the file. It turns out that there's another way we can write this code in Python. It kind of makes it easier to know when you have the file open and when you don't. And it helps make sure that your file always gets closed. The two sets of code that you see here do the same thing. In the second one, we have a command, the one starting with. What this does is it opens the file just like in the first line of the first set of code. Then, the stuff that you want to actually do with the code is indented in, just like we saw with our conditionals and loops. For all that indented code, we can use the opened file, named myfile in this case. When we leave the indented portion, the file will be closed for us automatically. Now, either way you do this is okay, but an advantage to this second version is that you won't ever forget to close your file, since it's done for you automatically. However, the file is only open for the section of code that's indented. Let's look again at the earlier example we had, where we opened two files, one for reading, one for writing. The code to open those files is shown here. First, see if you can remember how we would close them. We will write outfile.close parentheses and infile.close parentheses. Note that the order we close the files does not need to match the order we opened them. We can close them at any time and in any order. It would be perfectly fine to reverse the order. Now, What if we wanted to use that other formulation for opening files, where we have a line starting with with, and the file will be closed automatically? How might that code look? In this case, we would have two with statements. The first one would say, with open mydatafile.txt r as infile. Nested inside of that, the second would say, with open results.txt w as outfile. We would have to be indented in from there for our text. Now, you can see that a downside to this approach is that if you have multiple files open at once, there could be a lot of indenting. It tends to work better if you have just one file open for a while that you're then going to close. If you'll have lots of open files, then it's probably better to open and close them on your own. All right, so we've got the ability to open and the ability to close files. We need to look at what we can do in the middle. We can do any of the normal code that we always have, but in addition, we can read from or write to the file, depending on how we opened it. Let's look at writing first, since it's easy to do. Writing works a whole lot like the print statement that we've been using. Here's an example. We start out with the name of the file we're writing to. This is the internal name that we gave to the file. In this case, it's my file. Next, we have a period, followed by the keyword write, followed by parentheses. Notice that this is a whole lot like the close command that we had before. As we learn more about Python, we're going to see more and more commands that kind of look like this, where there's a period, and then a word, and parentheses. Finally, inside those parentheses, we have a string. Unlike the print command that we've used before, we can't output numbers, only strings. Let me say that again. When we use this write command, we can only write out strings. We could output a variable that's a string, like you see here. Or we could create a string, even converting numbers if we have to. In the example you see here, we form one string by taking a string and concatenating it with another string that we get from converting a number. We have the string, the number of countries is, and then we want to add 196 onto the end. We convert the number 196 to a string by writing str and putting the number inside the parentheses. It's just like what we've done before when we want to convert a string to a number and put int or float around it. In any case, the output has to be a string. Now, I said this was like the print command, but there are actually some important differences. As we just saw, the write command can only write strings, no numbers or anything like that. Also, the write command can only write one string. You can't put in separate strings separated by commas, the way you could with a print statement. And finally, the write command does not put in a new line character at the end of each line you write. With print, every time we print something out, it comes out on a new line. With write, that's not the case, and if we want there to be a new line, we need to explicitly write out a new line character. Have you got all that? Let's try another example and see. Say we've opened up a file using the with formulation. We have a couple of variables, volume1 and volume2, that have been computed previously. How would we write out to the file a line, the first volume is volume1, and then a second line, the second volume is volume2? We would have two lines, very similar to each other. They'd be indented under the with statement. Both would start with the name of the file variable, which in this case is outfile, followed by .write, and then in parentheses, the string we want to write. Notice that to include the volume1 and volume2 data, we need to convert those values to strings, and we need to use the addition operator to append them to the text string that we wrote, so that it's still all one string inside parentheses. We also add on a new line character. Remember that the strings we write don't automatically have a new line at the end, the way they do with a print command. So, writing the new line character is the way we make sure it's actually a new line. Okay, let's turn to the other side, where we want to read instead of write. First, notice that we opened the file for reading at the beginning. When we read from a file, we're generally going to read in one line at a time. That line is going to come to us as a string. We'll get a string that's one line from the file. Let me emphasize this since it can get confusing. When we have the readLine command, we read an entire line from the file as one single string. That string will include the new line character at the very end of the line as part of the string. We need to assign that string to some variable, and so our command to read in from the file will start with a variable and an assignment operation, the equals sign. In this case, the variable name is line_from_file. To actually get that line, we start with the name of the file, which in this case is my file. Then we use the notation similar to what we've seen before. We have a period, then the keyword readLine, followed by parentheses. Notice how close this is to the close command. So, if you look at the code you see here, it's going to first open a file named filename for reading. Then it reads the first line of that file and puts that string into the variable line_from_file. It then closes the file. If we wanted to read another line, we would have just had to add another readLine command to read another line from the file. Let's say you wanted to actually output those lines to another file. Well, the code you see here would do that. We'd open another file for writing. Then, after reading lines from the input file, we'd write them to the output file. I'd recommend you pause to study this and make sure you understand how it's working before moving on. Let's see how this would work. Say you had a file containing some obscure but possibly important piece of information, like a Swiss bank account number, or the airspeed velocity of an unladen swallow. Assume the information is in a file called important.txt. How would you get that numerical value out of the file? First, we'd have to open up the file for reading. In this case, I called it infile. Then, I read in the first line of the file by calling infile.readLine parentheses, and assigning the result to the variable line_from_file. I can then convert that string to a floating point number, giving me the answer. At the end, I should close the file. Let me mention one more tip here. One of the things you often want to do is process an input file, to take all the information in it and do something with it. So you want to go through all the lines of the file, one by one. You want to take one line, then the next, and so on. Well, that should sound to you like a loop, and it is. We could write that loop the way you see here. When we try to read a line from the file, but we're at the end of the file, there's no more lines to read, we're going to get an empty string back. So, we can check each time we read a line to make sure it's not the empty line, and do whatever we want. Then we read the next line, and repeat this loop forever. Notice that we had to read a line first in order to get this to work. This is actually a really common operation when working with files, to go through the whole thing, and Python actually gives us an easier way to do it. If you look at this second set of code, it works the same way as the first set. But we don't have to explicitly write readLine, and we don't have to explicitly check for the empty string each time. All that is done for us. We just have a new type of for statement. We start with the keyword for. We then state the variable that we want to put each line in, which in this case is line_from_file. Finally, we have in, the name of the file we're reading from, and a colon. Again, this code is doing the same thing we did earlier. We read in one line at a time through the entire file. It's just a cleaner and easier to understand way to do this. Now, I said that when we read a file, we'll read one line at a time. That's the way we will generally process files, but it's not the only thing we can do. In addition to the readLine command, or the for_in structure for looping over all lines, Python allows us to read the entire file as one single string. The way to do this is with the read command. If the file is opened as the variable myfile, we call myfile.read parentheses to get the entire contents of the file as a string. We can then assign this string to another variable. Reading the whole file this way is sometimes advantageous in that all the data from the file is collected in a single string. From this one string, we can break the string up into many smaller strings by dividing it up into lines. Before going farther, let me answer one question that sometimes comes up. Suppose you've written a program in a word processor and saved it. Are you now able to write a program that can read that file that you saved from your word processing program? Well, basically no. Unless you specifically save the file as a text-only file, it's going to have a bunch of extra stuff in there that you don't expect, having to do with fonts and margins and all sorts of other formatting. It'll be saved in a format that's not even human readable. Basically, you do not want to read files unless they're simple text files, what your word processor might call plain text. Now, if you saved from your word processor as a text file, then sure, you can go ahead and read it in, using the readline command I've just described. So, how does your word processor save a document? And how do things like image files and audio files get stored? Well, these are all stored as what are called binary files. Rather than being in human-readable text, they're in a more compact, but less reader-friendly format of ones and zeros. When a program reads from a binary file, the program will have to read binary information, and then convert that into the data that it can use. When writing to such a file, a program must open a binary file, convert its data into a binary format, and write it. Now in Python, it's actually quite easy for us to take our programming commands for opening and closing text files and adapt them to open and close binary files instead. We just add a B onto the end of the string saying how we're opening the file. Instead of W, A, or R for write, append, and read, we'll write WB, AB, or RB for the equivalent opening on a binary file. That part's easy, and if you ever find that you need to read and write binary files, there are tools such as the Pickle module available to make that easier for you too. So, at this point, we know how to open and close files, we know how to read lines from them, or write strings to them. We need to talk a little bit more about how files are organized into directories and how our programs can access those files, wherever they might be. We've talked about opening a file by specifying the file's name inside the parentheses. But it's not just the name of the file that can be specified there. We can actually specify a string that contains both a path and the file name. The path gives the directory in which the file resides, also called folder, that the file belongs in. If no path is given, it's assumed that the file is in the same directory as the file for the Python code itself. The directory structure is the way that all the files on the computer are organized, in a large hierarchy. Now, some of these details will vary depending on which operating system you're using. On Windows machines, the base directory is designated by some letter followed by a colon. C: is the most common base directory. To specify a position, you specify each subdirectory using a \/ character. For my computer, for instance, my PyCharm projects are located in C:\users\John\PyCharm projects. On Macs, running the OS X operating system, a / is used to separate the directories. The Python commands can usually be accessed from /user/local/bin. You can also specify file locations relative to the current file's directory. To specify a relative path, the key thing to remember is that the ../ directory is the directory one level higher in the hierarchy. So, a path such as ../ ../programming would mean going up 2 levels in the hierarchy, then down into the programming directory. Okay, let's say that we want to specify a file named data.txt that's in a subdirectory of the current directory called data. On a Mac, we would specify this as data/data.txt. On Windows, we would specify this as data:\data.txt. Why the \\? To understand this, we need to first understand a little bit more about strings and how they work. As we've noted, Python files are written and read by default as strings. So it's going to be helpful to understand strings not only for specifying paths, but also for dealing with the read and write operations. Remember that a string can be specified by using either single quotes or double quotes surrounding a bunch of text. The two versions are interchangeable, and the choice doesn't affect anything about the way the string is stored internally in the computer. What if we wanted to use a word like that's in the text, though? Well, if we use double quotes, it's pretty unambiguous. The single quote in the middle is an apostrophe. But if we used single quotes to denote the string, the computer can't tell if the apostrophe is just part of the string or if it's marking the end of the string. We run into the same problem the other way around, if we want to specify a string containing quotation marks. If we use single quotes to denote the string, things are okay, but double quotes just confuse the matter. And if the string contains both single and double quotes, there's no easy solution. So, the way that strings handle cases like this is using what's called an escape character, specifically the backslash. In a string, if a backslash character is encountered, it means that the next character should be interpreted differently than usual. We've seen one instance of this before. The \n indicates a new line character. The backslash lets us know that this is not our ordinary character n, but a special one denoting a new line. Similarly, we can specify single quotes or double quotes in a string by preceding them with a backslash. So, a string denoted by single quotes can just include a slash before every single quotation mark, and a string denoted by double quotes can just include a slash before every double quote. It doesn't hurt to include a backslash before each one. Besides the single and double quotes and the new line, there are two other useful escape characters. First, \t denotes a tab. Can you think of what the other escape character might be? It's the double backslash. Since a backslash is used to mark other characters as escape characters, we need to have an escape character for the backslash itself. This brings us back to the directory specification strings. If we're in a Windows system, we need to specify a double backslash every time we write a string, since that's the only way the backslash will be interpreted correctly. Note that this goes only for strings specified in the program. If a user types in a backslash or a single or double quote, the input command will automatically convert the characters to the correct characters in the string representation. Since we've been on the topic of strings, I want to mention one more string issue. Sometimes we want to specify a string with multiple new lines. We've already seen that we can do this by including the new line character, \n, into our string. But it can be kind of a pain to have to explicitly type in new line characters when it would be nicer to just see the text written with line breaks already displayed. So there's an alternative way to express strings, and that's with 3 quotes in a row. 3 quotes in a row will begin a new string and let it continue, new lines and all, until the matching 3 quotes are encountered. When specified this way, all the new lines in the middle become part of the string itself. The triple quote string is also useful for creating multi-line comments. The hashtag comment is the most common. But in cases where a comment might need to span multiple lines, it's acceptable to use a triple quote multi-line string as a comment. Keep in mind that as you work with files, you're bringing in data from external sources that you have little control over. There are a variety of problems that can happen when reading. A file might not be in the right format, or it might not exist in the location you expect. And it can be easy to cause problems when writing. Opening up an existing file to write will wipe out the old file. So stay vigilant. As long as you take care when working with files, huge boosts in productivity are possible. Writing data into a file is basically a matter of formatting your data into strings. You want to output data in a way that it can be read in easily with the read command. Thus, keep in mind that you'll want to separate your data appropriately so that you can process the data as it's read in, to pull out the necessary information. This means working with strings, which also comes in handy when you need to read or write to a location other than the Python default directory. There are a variety of other string manipulation routines we can use with files, but to understand how they work, it will help us to see some new ideas about how to structure our data, including the programmer's version of a list. So, in our next lecture, we'll look more closely at tools for working with large amounts of data, especially in lists, but also in other data structures. I'll see you then.